Hi, welcome to my video on graphing different forms of a parabola. One of the forms of a parabola is what we call the vertex form, where vertex form is y equals a outside of x minus h all squared plus k. And to graph the vertex form, we pick out the vertex from the equation, which is the opposite of plus 1, which is a minus 1, and 2. So h is negative 1, and k is 2. So when we have the vertex found, we place the vertex in the middle of the table, x comma y, and we take the values of x to the right of that, which is 0 and a 1. We take the x values to the left of that, which is negative 2, negative 3. When we plug 0 into the equation, notice we get 0 plus 1 is 0. Oh, let me write it down. When I put 0 into the equation for x, that gives me the negative of 1 squared plus 2, which gives me negative 1 plus 2, which is 1. And we know that if you move to the right 1 unit, if you move to the left 1 unit, you get the same y value. So now let's plug 1 in. Negative of 1 plus 1 squared plus 2. Again, we do the bracket first to get a 2. Then we square it. And when we square it, we get 4, and the negative of 4. Negative 4 plus 2 is negative 2. So we get a negative 2. 2 units to the right, so 2 units to the left is also a negative 2. So let's plot these values. The vertex is negative 1, 2. X is negative 1, y is 2. And we got x is 0, y is 1. X is 0, y is 1. X is 1, y is negative 2. X is 1, y is negative 2. And so on the other side, negative 2 gives me a 1. X is negative 2, y is 1. X is negative 3, y is negative 2. X is negative 3, start at 0, 0, negative 3, negative 2, right there. So we have a parabola that's doing this, and there it is. So notice, and again the parabola is opening downward through these points. It's downward because a is negative 1. A is negative 1, so therefore it's going to open down. Makes sense. And if we want to find the y-intercept, y-intercept is when we let x equals 0. Well, that's already done in the equation when we did or in the table of values. When x is 0, y became 1, so that's 0, 1. That's the y-intercept, which is right there. But what about if we wanted to find the x-intercepts on this graph? Well, to get the x-intercepts, we let y equals 0, so we go negative x plus 1 all squared plus 2 equals 0. I'm letting y equals 0. And now I'm going to expand this equation, so I can go negative x squared plus 1 equals negative 2. I move the 2 over to the right side, make negative. Divide, multiply both sides by negative, so x plus 1 squared equals 2. The negative times negative is positive. Negative times negative 2 is positive. And I have the square root of x plus 1 squared is plus or minus the root of 2. I did the square root of each side. So x plus 1 equals plus or minus the root of 2. So x equals negative 1 plus or minus root 2. So x is negative 1 plus root 2, or negative 1 minus root 2. And notice the two x-intercepts are not integers, so we have to approximate. The square root of 2 is 1.4, so we get a 0.4 and 2.4, so it's roughly there and there, but they're not good x-intercepts. These are not good x-intercepts. So this one right here is a -1 plus root 2. And this one right here is a -1 minus root 2. And again, change your root 2 to a decimal and add on -1 and you'll get approximately that point, but they're not good. So that's the graph, but the x-intercepts are not integers. Okay, that's graphing the vertex form. Now we have another form called, this is y equals ax squared plus bx plus c, and that's the standard form of a parabola. So we have, how do we graph the standard form? Well, one way is to say a is 1, b is 4, c is -5. So we can graph it by getting the vertex and plotting the vertex. We can also graph it by getting the y-intercepts and the x-intercepts. So let's get the vertex by doing -b over 2a. So b is 4, so -4 over 2 times 1, -4 over 2. So the x-intercept of the vertex is -2. So now I'm going to plug -2 for x into the equation. And when I do that, plug -2 for x, 4 squared minus 8 minus 5, I get a -9. So I have a vertex of -2, -9. So I can plot that vertex of x is -2 right here, and -9 is 5, 6, 7, 8, 9. There's the vertex there. I could use the table of values and work out the other, get the vertex form if I want. I can go y equals x plus 2 squared minus 9. That's the vertex form. I could do a table of values as I did on the first page, but what I'm going to do now is I'm going to let y equal 0, and I'm going to find the x-intercepts. And so I let y equal 0, so x squared plus 4x minus 5 equals 0. And the x-intercepts, I'm going to factor. Notice this is factorable, probably. X squared is x and x. The product is -5. The sum is +4. So the factors of 5 are 5 and 1. Product is negative, so there's to be a plus and a minus. So it's a +5 minus 4. Multiply, -5. Add, +4. So x plus 5 equals 0, or x minus 1 equals 0. X is -5, or x is 1. So the x-intercepts are -5, 0, or also 1, 0. So notice y is 0, and x is -5 and 1. So x is -5, 0, which is right there. And the other x-intercept is 1, 0, 1, 0, 0, 1, 0 is right there. So this is the other x-intercept. So I got a vertex, and you notice, I'll explain that now in a minute. Let's look at letting x equals 0. If I let x equal 0, then I'll get the y-intercept of the graph. So I let x equals 0 in the equation. So I'll write down the equation so you can see what I'm doing. I'm subbing 0 in for x. That gives me a 0 and a 0 minus 5. So I have a y-intercept. X is 0, y is -5. X is 0, which is right here, and y is -5 here. So, and if that's the vertex is here, So I know that this is the vertex, this is the axis of symmetry, so that's 2 units to the right. So if I go 2 units to the left, I should get the same y value. So that means a -4 is going to give me -5, because there's the axis of symmetry. So 2 to the right and 2 to the left from this axis of symmetry should give me the same y values. So I have a parabola that's, try to draw it half decent. There it is. And if you have a graphing calculator, you can plug it in. I didn't want to use a graphing calculator. I wanted to do what we call the real math, working it out from knowing the properties, using your head. You can type in a graphing calculator and bang, up comes the parabola just like that. And I also want to let you see that the x-intercepts are -5 and 1, so if you add them up and get the average, you get a -4/2, you get -2. So the x-coordinate of your vertex is -2. That's another way to add the x-intercepts up and divide by 2, you get the x-coordinate of your vertex, which is also your axis of symmetry. Then if you had that value of -2, you could plug that into your equation, and guess what you get? You get your vertex, which is -2, 9 that we found out here. So there's another way to get the x-coordinate of your vertex, by getting the average of your intercepts. So everything fits together. If you can factor, you can work it out, you can get x-intercepts. Everything works together, all come together. Now we have another graph, and this is called y = a outside of x minus s, and we have an x minus t. This is called a factored form, or the X Intercepts form. And so as a result of looking at this, notice that a is 1, and notice that a is 1 and it's positive, so that means it's going to open upward, so it's going to do this. So just keep an eye on, if you graph, sometimes when you graph, you're graphing correctly, the extra information can help you. And we have x-intercepts, the x-intercepts. The x-intercepts are opposite of -2 is 2, and opposite of -4 is 4. So the x-intercepts are 2, 4. And that's true because the x-intercepts is when y is 0. So 2, 0 and 4, 0 fit the equation. So when you let y = 0, you're solving this equation. So really, each of these brackets are equal to 0, which gives you the 2 and 4. So the x-intercepts are 2. X-intercepts are on the x-axis at 2 and 4. And we have the x-intercepts, so let's get the average. So if you add them up and divide by 2, you get a 3. So that means that's the x-coordinate of your vertex, or your axis of symmetry. So if you take the x = 3 and sub back into the equation, I'm going to sub 3 in for x, and that gives me 1 minus 1, -1. So the vertex is a 3 and a -1. So the vertex is 3, x is 3 minus 1. And you can see going up from the vertex to these 2 points. Now let's let y = 0. And y = 0 gives us the x-intercepts. So we found that. We already got that done from up here because that's the x-intercepts. Let's let x = 0 in the equation. So we let x = 0 in the equation. X = 0 will give us the y-intercepts. The y-intercepts when we let x = 0. So take the equation, we put 0 in the place of x, we put 0 in the place of x, and that gives us -2, -4, 8. So the x is 0, y is 8. So 5, 6, 7, 8, x is 0. Right here, x is 0, y is 8 there. So we have a parabola that has a, again, notice I worked out, there she comes, that makes a bend. And this is 3 units to the left. Let's go 3 units to the right, because this is the axis of symmetry down through here. And that axis of symmetry is x equals 3. The x-coordinate vertex is 3, and y is -1. So if we go 3 units to the left, we get 8. Let's go 3 units to the right, and we get 8. And so a parabola is symmetrical, so we go on up through. It keeps on going up and up. And that's how we graph the X-Intercept form. Again, if I want, I could take the equation, which is X-Intercept form, and do a FOIL on it and get x squared minus 4x minus 2x plus 8. Y equals x squared minus 6x plus 8. And you notice this is the standard form. And when you let x equal 0, automatically y is 8. Perfect. So I'm just verifying by changing it to standard form. But again, I graphed it, getting the x-intercepts, getting the y-intercept, getting the vertex, and there's the graph. And remember, as you move 1 unit to the right of the axis of symmetry, the y values are the same. As you move 2 units to the right, the y values are the same. As you move 3 units to the left and right of the axis of symmetry, the y values are the same because the graph is symmetrical. So that's graphing different forms, but you're always using x-intercepts, y-intercepts, etc. Because when you let y equals 0 and x equals 0, you get the different intercepts of the graph, and you're solving equations. If you like my video, click the like button, subscribe button, the notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video.